All right, to wrap up chapter 1, we bring this home with a section of applications. So we've kind of stuck application problems throughout the chapter, but it's okay. This one is all applications, so there's not a lot of like additional theory that comes in here. So if you look through here, there's like two main categories that end up coming up, and that's a cost, revenue, profit type situation, and we'll see some economic market equilibrium stuff later on in the notes file. So we'll start with the profit, revenue, cost stuff. So profit you can generally look at as the difference between revenues and costs. So revenue minus cost, right? So that's where those formulas that we saw way back in the first section that were just kind of like hinted, like we just gave them to you without telling you what the notation meant. So in general, a revenue function, again, X is standing in here for the number of units that we make and end up selling. You've probably heard this before, revenue equals price times quantity, so like a PQ thing. This time around, that price times quantity thing still holds, we're just using our variable X as a stand-in for the price. So R of X is generally going to look like PX for us right now, so P times X. So cost is a little more complicated because it's technically got multiple pieces that go into it. You've got what you call your fixed costs, things like utilities and stuff that, no matter what you're paying those. It doesn't matter if the factory is closed, you've still got to pay a rent on it or, pay the mortgage or whatever. So those costs are fixed. They're set in stone. They don't change. Then you have your variable costs that basically you incur for each unit that you make, materials, labor hours, that kind of thing. So your cost function, your C of X, if you know the fixed cost and you know the variable cost per unit, you can basically write it like so. So again, the F and the B and technically the P up here, for now they're all standing in as like, fixed, real numbers. So F plus VX is your cost. PX stands in for your revenue. Okay. So let's take a look at this in the context of an example and end up seeing what happens. So this first example that we've got listed, we're making calculators. We sell them for $25 each. All right, well, that's straightforward enough. We know our sale price. So R of X, this is technically part number 1 under the example heading, but our price, we've already said, is 25 bucks. So R of X is just 25x. Done. There's not really much else to it at this stage. Now, next, we want the cost function. So we take a look at C of X, and again, we need to know our fixed cost, and then we need to know how much it costs us, per calculator to do assembly and, whatnot. So we've got it labeled here that the cost, it says $21,000, no matter what. So that's our fixed cost. Then it says plus $4 for each calculator. It's almost like somebody took like the equation and then just kind of read out what it should mean. So our fixed cost, no matter what, we owe $21,000 to the power company or something. And then we incur an extra $4 for each calculator that we assemble. All right, so we've got our revenue, we've got our cost. We've done the first 2 of these guys already. So the next thing we're asked for is a profit function if we make and sell X calculators. So the general formula for profit, you can hop back up to the very top of the notes thing. It's listed. R of X minus C of X. And we can just fill in the blanks. Take this formula, put it down for R of X. Same thing for C. Now it's important. It is important to make sure you do include those parentheses because it will throw things off if you don't. Both of these things need to get multiplied by -1. The sign needs to change on both of them. Don't just get in the habit of writing minus and then copy and paste. Because that'll end up throwing things off if this variable cost is somehow now turning into a net gain for your company. That's not how that works. So our profit function in this instance, now we can kind of gather up common terms. 25x minus 4x. We're going to have 21x. Then we have minus 21,000. That's our profit function P of x. Now the final question that ends up coming up here, it says, how many calculators are we going to have to sell in order to break even? So we talked about that break even point previously. Now, there are technically two ways you could do this. You could do it exactly like we did back in the first section and say, well, I'm going to take my revenue, I'm going to take my cost, I'm going to set them equal and then solve for X. That's perfectly valid. There's another way I'm going to take a look at it here, though, because it involves something we've already worked out. So we're going to find a way to be able to use this profit function. So if you're breaking even, how much are you profiting? Pause for consideration. That's right, breaking even means you're making nothing. You're right at zero. So the profit is exactly, as you say, is exactly zero. So to get that last bit, the break even point, we can take our profit function from over here and set it equal to 0. And now it's generally a lot easier to get x by itself there. You don't have to do quite as much work. We've already done it in assembling the profit function in the first place. So we have 21x minus 21,000 equals 0. Now we do our usual algebra routine. Add over the 21,000. He's now going to be on the right-hand side. We divide both sides by 21. So we have 21,000 divided by 21. That equals 1,000 calculators that our company has got to manufacture and sell in order to hit the magical break-even point before we actually start making money. We start, being able to pocket something. All right. So there's a second example in the notes that does more of this, revenue, cost, profit calculation. I'm going to leave that one for you to practice on. It's actually labeled like, number 3 a few pages in, talking about, somebody who makes and sells books of checks. Checks, they're actually still a thing. So I'm going to hop over that one and leave that to you because it really is just more of this process with kind of different numbers in place. So I don't think it's a good use of, somewhat limited, video time here just to repeat the process. You can take a crack at it. Of course, if you want to ask me questions, I'm happy to take a look at them. But I did want to take a look at some stuff on this next page here that talks about marginal quantities related to the same cost, profit, revenue thing. So we've got definitions listed for marginal profit, revenue, and cost. Oddly enough, as it turns out, the definitions, they all look alike. So you've got this notation MP bar for marginal profit. And as it turns out, what that ends up meaning is rate of change of profit. Technically, with respect to units sold, how much more money do you profit if you sell another unit is kind of the idea here. So the other two definitions underneath, they follow exactly along the same lines. If we were in a classroom doing this together, I normally like to draw a line through profit and then write revenue up above it for marginal revenue, and then the same thing happens for cost. So the magic part of this is all of the functions we've been dealing with so far have all been linear. So everything we've dealt with before is linear. And we saw back in section 1.3 that rate of change for a linear function is exactly the same thing as slope. So now, when we get to some other types of functions later, we might lose that niceness. But for now, if we can figure out the slope of our p of x function, which it's like the coefficient of x, that's typically not too tough, then we've got what we need. And this same process repeats for revenue and cost. Replace P of X with R of X and C of X. Like I said, I think that makes sense. It always feels weird that I make people write that down. So you get the idea, hopefully. All right. So coming to the example that ends up coming up here. So we've got a cost function. It's written in that mx plus b form, so we can actually pull out what we'd have called the slope and the y-intercept. Now it's the c-intercept because our dependent variable is c instead of y. But so the c of x, I'm writing it down just so I have it to point out on the board. But you've got it in front of you. So we have 11.02, and that should have an x on it, plus 2,072. So the slope is that guy right there. This guy is my c-intercept. So Check on A. So it asks us what the marginal cost is. And you could technically work this out by saying, well, let's figure out a number of units and then increment by 1 and see what changes. But we've already kind of mentioned that the rate of change and the slope are one and the same thing. So our slope is right here. And what that ends up telling us is that each unit we produce cost us another $11.02. So the increase in cost per unit produced, if you want a raw definition there, or like a raw sentence there. And that kind of answers D at the same time. What's the cost of producing another item if we're making 50? Well, it's 1102. Same thing if we're doing 100. Since our cost function is linear, it's not like it climbs like more rapidly or anything. It's $11.02 for each one. And like we said, the marginal cost and the slope are in fact one and the same thing. So, all right. So moving on to our final example that I want to look at in this video, we've got cost and revenue functions given. This is our C of X. Then we kind of tack an R of X onto it. So our R of X is just 11X. And then we're asked to find the marginal profit and what it ends up telling us. So same old R of X minus C of X routine. If we subtract this cost guy from this 11X, we should end up getting the following. Negative 0.02X minus 2072. And then it asks us what that means. The fact that this is negative, like I said, if you think of this as a rise over run, negative means that's not a rise. It's actually a drop, right? So we're losing 2 cents on each unit. I'm not really a business professor. I'm a math teacher, but this is generally bad that you're losing money on everything that you make and sell, right? So we probably need to figure out how to fix that. Now, for what it's worth, it says underneath, what should the firm do? Well, I guess on the one hand, you could just close. That's assuming you don't just want to close. We've basically got 2 options. You could technically try to find some way to bring down this variable cost. Changing the fixed cost doesn't help. Negotiating better rent's not going to alter the fact that we're losing 2 cents per unit. Either we find a way to lower our fixed cost, or, and this one might not be quite so popular, we might need to target that price per unit that we're selling in order to increase our revenue stream, which that one you've probably got a little more control over. If you've done your job right, you might already have the fixed cost more or less as low as it can go. But I know raising prices is never a popular move, but that seems like the best thing to do if you don't just want to close the doors for the company. So I guess we have 3 options. Raise price, cut fixed cost somehow, or shutter. So I'll leave that up to you as to which one is the appropriate decision for a given company. But so that's it for the cost, revenue, profit stuff. I want to come back and take a look at this market equilibrium content at the end of the notes file in our next video.